Okay, so this video here, we're going to review valence electrons because you're going to need to know the valence electrons for your Lewis stat structures that we're going to go over the next couple videos. All right, so if you remember, if you look at your electron configurations for, say, oxygen, all right, oxygen, which has 8 electrons total, is 1s2, 2s2, 2p4. All right. So the valence electrons are the electrons in the highest energy level in the S&P suborbitals. So that means oxygen has 6 valence electrons. All right. Sound good? So now, so you don't have to write out the electron configuration. You can just look at the atom's position on the periodic table, and that'll tell you the valence electrons as well. All right, so if you look, now we'll start with over here, the noble gases. All right, well, the exception of helium, which we know is just 2 valence electrons. All the other valence electrons, or all the other noble gases, they have 8 valence electrons. If you go to the next group down, the halogens, fluorine, chlorine, bromine, iodine, they have 7 valence electrons. And then the oxygen group has 6, nitrogen group has 5, carbon has 4, and the boron group has 3 valence electrons. All right. Now if you go over here to the left, hydrogen, lithium, sodium, potassium, they'll have 1 valence electron. And the second row, beryllium, magnesium, they have 2. All right, now, just for now, just for purposes of making this easy, valence electrons in the transition metals, we'll say that varies. Right, because as you know, transition metals, they can form anywhere from a +1 charge, +2, +3, +4 charge, multiple. So that could get a little complicated because of those d electrons being filled in there. So for this unit, we're not going to really go over the use of transition metals for our Lewis stat structures. Right? So that is how you figure out valence electrons. Right? So if we want to say, okay, how many valence electrons are in aluminum? Right here in this group has 3. Iodine all the way over here has 7. Strontium has 2. Right. So using that leads to our Lewis stat structures. Okay, Lewis stat structures, also called electron dot structures. It consists of a symbol, so just the symbol of the element, and that represents nucleus and the core electrons. And then we have dots around it. Those dots represent the valence electrons. Okay. Now, when we write out Lewis stat structures, we put the electrons typically in pairs or in singles. Okay, we do not triples, etc. or etc. All right, because that's, we talk about pairs of electrons when we talk about shapes of molecules, and also we have, the single electrons here. Typically, we call those bonding sites. That's where those single electrons will go and look for another single electron, another atom, and that's where bonding takes place. So, if you see here, neon, our noble gas, has 8 valence electrons. Well, there's 1, 2, 3, 4, 5, 6, 7, 8. So we just put 2 on top, and then 2 on the bottom, and 2 on each side. All right, with fluorine, okay, fluorine has 7 valence electrons. So there's 2, 4, 6, and there's our 1 there. That gives us 7. Oxygen, 6 valence electrons, 2, 4. And now what we do is we just split these up to make these 2 bonding sites. When we start Lewis stat structures in the next video, you'll see how that works. You can also, it's quite all right to do this. And in some cases, when we start doing examples for Lewis stat structures in the next video, you'll see when this will come into play. All right? Silicon, 4 valence electrons, 1, 2, 3, and 4. So nice and easy how to write those out. You do not have to start them on top. Typically they just do that. The single electrons, they can be anywhere. So you can write oxygen as 1, 2, 3, 4, 5, 6. Again, not that big a deal. All right, so just to clarify that. Right. If you look at something like nitrogen, with 5 valence electrons, then you would do 1, 2, 3, 4, and 5. So that's how nitrogen looks. All right, so we do that with all the elements with the Lewis dot structures, if writing them just as an element. Okay. So in the next video, what we'll do is we'll show you how to do ionic compounds with Lewis dot structures.